Okay, so I have a small cylinder that has only, well, it's basically, would that be 200? It doesn't matter, it's kilograms. Okay, so 0.2 kg. And the static friction is 0.08, and the cylinder is located 0.515 meters from the center of the turntable. What magnitude of the acceleration due to gravity? Oh, that's not the question. What is the maximum speed that the cylinder can move before it slides off?
Coefficient of friction. It's really small though.
So it doesn't matter.
I know.
It's just a number.
I know. I'm just thinking like that. That's pretty small. That's like rolling friction or ice.
Oh yeah, it is pretty small for static friction.
Mm-hmm. Okay.
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 All right.
First
let's
step.
get started.
First step.
Yes, the first step
Mm-hmm.
is to solve the problem.
That's the third step. FBD? What is
But these
FBD?
never help me.
They do.
They don't. I draw them and then I'm like,
Oh.
this doesn't help.
A lot of times that's just because we don't know how to read them. And
Okay.
that just takes, that's like everybody. At the beginning when I first learned how to do them in my engineering classes, I'm like, what are these?
Well, I get their purpose, it's just
Yeah.
they don't help.
Oh, I know, that's like what I'm trying to say, I think. They're ridiculous.
Okay, we'll start out with the pre-body diagram just to ease your subconscious.
Well, I'm just saying that because from your free body diagram, that's where you get your sum of the forces. And
Well, I
that's,
know the sum of the forces has to be going.
I mean, all of the forces. Because a lot of times we will forget a force or we'll misplace it.
It's
Especially,
already told us every force.
okay. Do you want to try it?
I don't even know what equations to use.
Okay. Well, we don't worry about the equations because we're just worrying about forces at the moment.
Okay.
So,
Okay, so we have something turning. I don't know which perspective you want.
just whatever you want, whatever you want to do.
Okay, for Y, we only have gravity and normal force. That's it.
What else?
That's it for Y.
Okay.
For X, we have a static friction, and we have a position, but that's not really a force. And
So where's friction going?
it's going, wouldn't it be trying to stop it from going off this edge?
Maybe. So which way is that?
To the right in this case.
Is that going to be positive or negative?
Well, static friction's usually negative, isn't it?
Depending on which way you're going.
Well, it shows the cylinder on this side of the thing,
Okay.
so I'm supposing that static's going to be on the right.
Pointing to the right?
Yes.
Okay.
Okay, that tells me I'm wrong.
No. It just depends, just your reference frame.
Well, you looked at the picture.
I know. I know, yeah.
That's not going to look good on camera.
What?
The piece you just pulled.
What, this one?
Yeah.
Okay, look at it out. See, if it's rotating that way, then the block wants to move that way. So static friction is going to be pointing inward, trying to keep it on the block.
Well, even if it was turning that way, it'd still be moving inward.
Yeah, so the friction is going to be pointing inward,
Yeah.
not outward.
Who told me wrong?
Who did?
This TA. Okay, so it's moving to the left.
Okay. See, this one's super simple. So you don't really need one, except if we were to continue on how the TA taught, it'd be wrong.
Thank you.
So this is an example why we use them. Even though you might seem like they're dumb and that you don't need to see any use to them, they do help.
I see they use, it's just they don't help me.
Like on the more complicated systems, they will.
Okay,
Yeah.
pray continue.
Okay. So you have your normal, your friction, then your friction thing. This is gravity.
Okay.
Basically, this is what you saw in your mind.
Mm-hmm.
So normal. Then what is this equal to?
Which one? The x?
Yeah.
Wouldn't that be equal to mass times acceleration? Oh. Why not be?
Yeah. What else is there? Which way is our normal going? Mass times acceleration. Which way is our acceleration pointing?
Towards the center.
Towards the center. Okay. Just go like that. Just happens in this time that. Why is that a negative? Is that confusing you?
No.
Okay. So it just happens in this case that it's going to make them both positive because there's only two and they're both negative.
Mm-hmm.
So that's nice. It's a happy day.
Happy day.
Happy day. What's your formula for centripetal acceleration?
Is that the b squared divided by r?
Yeah. Perfect. See, you know it. Good job.
I just think I know.
Very nice. Very nice. What's your static friction force?
0.080. If you want to add that extra zero. But
Mu. So that's your mu. Then what?
why do I have to use mu? It tells me what it is.
I don't know. We're solving it symbolically.
0.08 is what it is.
I know.
Why are you doing this?
Because symbolically is better. Just on that, it's ridiculous because it wants a specific set of answers. Not the one before. It needed a specific answer.
Because this wants the answer too.
I know. Yeah, I know it wants the answer. I just, it's, if you ever go on in physics and
I probably
which major again?
computer engineering.
True, okay, never mind. So you won't go further on into physics. It's always a good lesson, or it's a good thing in life to have an equation for everything. So if we were to solve it symbolically, then we would be able to use that answer that we get for any situation like this. And in programming, I would imagine that you'd like to reuse your programs. Like you,
I just copy and paste.
exactly, yeah. Like you don't recode everything. That would just take
just
forever.
call functions, okay?
Exactly. Yeah,
It's totally different.
That's exactly what we're doing. We're calling a function.
No, you're not. You're calling a weird, obscure variable called mu.
So,
It's different.
though somebody said some time ago that mu was the coefficient of friction. Kind of like what we did right here. We said our acceleration.
Right.
Well, never mind. Whatever.
Okay.
Fine. 0.08. What's your normal force?
That would be 0.2 times 9.8.
What is that?
I calculated and figured it out faster than I can.
Nice. Now, honestly, I only know like one person or two people that can do math really fast in their head. One person, really, that comes to my mind. It's my engineering teacher. He just does like 3-digit numbers in his head. It's like 3,000 times, 3,250 times 0.028. It's like, well, that's 27. Okay.
So that's 1.96.
Cool. Then what's your mass?
0.2.
0.2. If we had kept it in your variables, you would have found out that your
Well,
masses
I know
cancel.
masses can cancel.
But now we have to do that math. Actually, you have to put it in your calculator and divide by 0.02.
No, we don't.
Yeah, you do. Because you already times your mass together with your
No,
gravity.
I just know it's 9.8, so,
Yeah. That's a simplified version. But yeah, okay. It's not better to do it with numbers, by the way. I'm just saying that.
It's not better to do it with
No.
numbers?
Like, just putting in your numbers at the start, because one, there's a lot of round off error.
True.
And if we have a calculator that doesn't hold all the data in it, I think that one does. Does that one? But if you don't, like if you have like a Casio or if you have like a TI 30, then you have to write down all the numbers, and you get a lot of round off error. So if you hold it all as variables till the very end, You don't get any round off error.
So can't we just cancel out the masses now and say it's 0.08
Yeah.
times 9.8?
0.0 times 9.8. Yeah.
And that's equal to velocity squared divided by r?
Yeah. What's velocity?
I don't know velocity.
What's your R?
R is 0.15.
0.15. Okay. Is that meters or centimeters? Or kilometers?
Meters.
Cool. Are all these in kilograms or in...
Well, the static doesn't have anything.
Yeah, true.
And then it's in the standard units.
Good, good. It's always good to convert back and forth. So then you just take that over here.
Mm-hmm.
What are we looking for? I can't remember.
The velocity.
Cool.
Okay, the square root, no, not that. The square root of the, no, I can't control this thing. 7.22 meters per second. And that makes sense.
Nice.
Okay, only two significant figures. So that would be 7.2. What? Why am I wrong? Tell me why I'm wrong. I should have been right.
Mm-hmm.
Is that how fast it can go without slipping off?
Yeah. Should be. One second, let me see.
Oh, maybe I didn't. Oh, there's my problem.
Huh?
I did 0.8 instead of 0.08.
Okay.
That will be a problem. Oh, what? Square root of the answer will give me 2.3.
I've been noticing this is a very common thing right here. This combination. Gravity times radius under the square root. It's like...
Why am I wrong again?
What are you getting?
I'm getting 2.3.
Let me see. Can I see your calculator real quick?
I don't see why I'm wrong. I'm taking the square root and everything.
Square root of 0.08 times 9.8 times... What's your radius? 0.15.
Oh, times, that's why.
It's 0.343.
0.343.